Just something to think about. M squared minus 12m plus m. Fill in the blank to make a perfect square trinomial. All right, so that's you're trying to find the number that goes here. It's something that we've done a number of times. It's based on this number in the middle here, but usually I give you the number over here. Any idea how to do this?
So you gotta, it's the blank, you gotta divide 12 or minus 12m by 2.
That's right. Okay.
Or m minus 6.
Good. And then
you got 36.
Yes. Now is it positive or negative 36?
Positive.
It is. Very good. All right. One down. You're doing great. You can't get them all right if you don't get the first one right. That's the key here. All right. This one is, I'm going to give it to you without the multiple choice. Kind of easing into this. All right. So take a look at this. Figure out what goes in parentheses there. This is very similar to the last one, so.
All right. C plus 5.
Yeah, very good. So let's say it was C plus 5 squared equals 17. And we want to solve for C. What's the next thing to do here?
Gotta find the square root of both.
That's right. So it becomes C plus 5 equals plus or minus the square root of 17. Is that a known value? Do we know the square root of 17?
No.
So we got to leave it like that, unfortunately. All right, so now to close this out though, how do we undo plus 5 here?
Do -5.
Okay, subtract 5 from both sides. I always recommend putting that in front. So it's -5 plus or minus the square root of 17. Good. Any questions on that?
No.
All right, so kind of a true test of like where you're at in this, your understanding is a problem like this one, because it says to solve the equation, find all the solutions, basically solve the equation using any appropriate method. Basically saying like, we're not going to tell you how to do it. You can decide. And you have to look at this and maybe look at the answers, and maybe it will help. Like A and B are kind of like completing the square answers or quadratic formula answers. And then C and D are more like factoring answers that are nice, we'll say. So what do you think here? When you look at this, x squared minus 8x minus 20, what do you hope it is? What kind of factoring do you hope that this works out to be?
Like an A equals 1.
Yes. Now let's try that. Are there two numbers that multiply to minus 20 but add to minus 8?
Minus 10 and 2.
So is your answer C, or is there something else to do? So to answer that, it's a good idea to write out the binomials.
Oh, yeah.
Okay.
So it'd be positive 10 and negative 2.
Yeah.
Is the final answer.
Yeah. So letter D would be the better choice there. All right, here's another one to look at. Let me see, actually see if this one works out nicely. All right, I'm trying to find some that make some sense here. Okay, I guess we don't have that option. All right, let's look at the next one here. I'm going to tell you that this is quadratic formula. So do you remember quadratic formula from a while ago?
Yeah, the big and complex equation.
Yes, so I'll write that out for you. Minus b plus or minus the square root b squared minus ac all over 2a. What I'd like you to do is tell me the values of a, b, and c.
A is 1, B is -8, and C is -2.
Okay. Now I suggested when we did this before that you do what's called the discriminant. That's the part under the root first. If you want, I can check your answer. If you don't want, you can try working it out all the way through from here.
Yeah, I'll do that. I'll do the letter.
Okay. How are you doing on this one? Do you need me to check anything for you?
I got 8 plus or minus square root of 33.
So it sounds like you're gonna be like the top part. You got 8 plus or minus 2, or did you fully simplify?
Not yet. That's where I'm at.
Okay. So what did you get under the root? That's what I'm really curious about.
66.
Good. All over 2 times 1. Yes, this is good so far. meaning you've done everything right up to this point, and well, a little bit more to do. The square root is 66. Do you remember how to reduce that?
Got to do the factor tree thing.
Break it apart, unfortunately. Yeah.
I can't square root it.
What? One more time. Sorry.
Because if I try to square root or do the factor tree thing with 66, it goes back to 66.
Yeah. So unfortunately, like this one doesn't work out nicely, although I thought it did. I'm trying to look at this again here. B squared is 64. Oh, boy. There's a 4 there. Okay, that's why it's not working out. Sorry about that. So sorry. So that changes this too. And let me finish this problem up for us because I did that awful. I was looking at like, man, that doesn't, she's right, that doesn't work out. So B squared is, we got -8 squared minus 4 times 1 times -2. So that's 64 plus 8, 74. You look at that maybe at first, it also doesn't work out because it's supposed to be 72. Having one of those days. Okay. So 2 and 36, 2 and 18, 2 and 9, 3 and 3. So yeah, 2 and a 3 come out basically. This works its way back into 8 plus or minus 6 square root 2 over 2. And here you divide both of them by 2. Okay. So it becomes 8 over 2 plus or minus 6 square root 2 over 2. So that's 4 plus or minus 3 square root of 2. That's your two answers.
All right.
Is that okay?
Yeah.
All right. So we're gonna just kind of transition a little bit from that. So if you want to get that down, that's fine. I will send you the notes at the end as usual. Okay. So next grouping of problems here, I've got 4 different quadratics. And we're going to look just at A for the moment. The vertex of A, I'm going to put here to the right. The vertex of A is 4, 3. Can you tell me the vertex of B based on that?
Oh, yeah. It would be 4 minus 1, right?
Yes, yes, very good. Okay. And then we'll go over and look at C. The vertex of C is 2, 3. What's the vertex of D?
-2 minus 1.
Why is this one negative all of a sudden?
Oh, that confused me because it's the thing where you would think it would be the left on the graph, but it's right.
That's right. Yeah, this one's 2, -1. The middle one is the most difficult one. You know, anything inside parentheses is gonna be really tough. So let me give you a couple more here to try. Or We look at the actual problem. So let's say it's y equals minus 3x plus 3 squared plus 1. Excuse me. What is the vertex of this? This time it's
-3.
yeah, minus 3, and then
-3 and 1.
yeah, you got it. All right, so here's a problem for you to look at. All right, so take a look at this. Give me your final answer, please.
All right. -2, -10.
So which answer would you select? A, B, C, or D?
Oh, B.
Very good. Now, the other way to find the vertex is to use formulas. We might have been doing this the other day with the tables and stuff. So the formulas are something like this. So it's ax squared plus bx plus c. The x coordinate of the vertex is minus b over 2a. All right. So let's look at a problem that we've already worked on. So here's an example here. Let me snip this in. Let's say you've got x squared minus 8x minus 2. Could you use this formula here to tell me the x coordinate of the vertex?
-4.
Yeah, so it's minus x equals minus a minus 8 over 2 times 1, which is 4. Very good. Now to find the y coordinate, you put x back into the equation. So you're gonna 4 squared. I show it as substituted in parentheses minus 2, like that. Will you simplify that for us, please?
-14.
Okay, so we got 16 minus 32 minus 2. It is minus 14. Very good. Okay, so there's two parts to finding the vertex when you use formulas. The first is to find x. The second is to put that x value back into the equation to find y. So sometimes it's more involved than just reading it off the vertex form. So here's one for you to try. I'd like you to determine the vertex of this one, please.
All right. I got minus 18, or wait, no, I got 4 and minus 18.
Okay, so your first value is off, unfortunately, and that's gonna like mess
Oh, wait,
everything
no,
up.
3.
Yes. So let me just so that gives you that gives you 3. And then did you put 3 back in or did you put 4 back in?
I put 3 back in. I just looked at the number 4 on my paper and I was like, yeah, that's the one.
And I'm sorry, what did you get for the y value? Because I was focusing on your x.
Negative 18.
Okay, so small error there. Let's take a look here. 2 parentheses 3 squared minus 12 times 3 minus 18. So in this first position here, you square before you multiply.
Okay.
You square before you multiply. So that's 9 times 2 is 18 minus 36 minus 18.
Minus 36. Yeah, so it's 3 and negative 18.
So I think you just, so do you see what's on my screen here?
Wait,
18,
no, I just did. I did it again.
the two 18s cancel 18, and that leaves you just minus
Negative
36.
30. Yeah.
There you go. Good. Okay. I'm gonna have you do one more of this type, a little bit different though. We'll see if that is an issue. But here's the equation: y equals minus 3x squared plus 5. And I just want the vertex using the formulas. Any questions on this one or anything you're unsure about?
So B. Just to make sure, when it's only 2 of them, then C would just become 0.
It's actually that it's plus 0x plus 5 is the way to write it. How does that
Oh.
change what you just said? What is actually 0 in this case?
So it would be B then.
Yes, B is 0. So it's like minus 0 over 2 times minus 3.
Still 0.
Still 0. Okay. And so that's x. to find y, you have to put that back into the original there.
So it'd be 0 and 5.
Yes, perfect. All right, so let's try something different here. Let's start looking at some graphs. I'm going to put a graph in front of you and start asking you some questions. But before I do that, let's just talk a little bit about some things that all graphs have. All graphs have a y-intercept, okay? And this is where it crosses the y-axis.
Yeah.
And that's the vertical one, okay? Some, but not all, have x-intercepts. This is where it crosses the x-axis. All the parabolas will have a vertex. It's either the min or the max. And there's two questions that you could be asked. I could ask you, where is the min or the max? And then I could ask you, what is the min or max? Is the language there? Do you see the difference in the language? It's not the same to ask where and what in this context.
Yeah.
Sometimes we use them interchangeably when we're rambling in the case of me, but in the math world, you've got to be very specific here. All right, so just a little bit of primer here for this. So let me put a graph in front of you, and I'll take these in any order. Can you give me the y-intercept, x-intercept, the vertex?
Is 8.
So 0, 8, it's an ordered pair. They're all ordered pairs.
X. X has 2 of them, so I'll just
Okay,
how
give
do
me
I
the
go about
first.
that?
Give me the first one. Give me the second one.
2 and 4.
So ordered pairs. So 2, 4 is up here. I know that's not what you meant, but just keep that in mind. You don't mean that point. I want the point, this ordered pair and this ordered pair.
2, 0, and 4, 0.
Good. So I was a little deceptive. I didn't say that there were 2, but you found them both. Very good. How about the vertex?
Escaping my mind. I gotta look back in the notes.
The vertex is the min or the max. It's that point right there. It is a min. What is the ordered pair there?
3, -1.
Okay. Now, what I'm going to do next is give you a question based on the graph. So just give me a moment here to snip this in, but because you may need to re-identify some of these things. So just be clear on how you found them. Let me know when you kind of feel good visually about what's going on here. You're going to get the graph again. I'm not going to hide that from you, but. Okay, let's take a look at a question. There's a question. Let me grab the graph. There's the graph. And if you need a hint, let me know. I'll give you a hint, but just take a look at this first. Would you like a hint?
No, it's B.
Okay. Okay. And how sure are you of your answer?
Very sure.
You are correct. Good. Okay, let's do another one like this. It's really odd. In the same document, they made a really nice graph, and then this one is clearly like copied out of some other ancient textbook. Because the one I just showed you was made nicely. So I don't know. This one looks pretty terrible, but you can still do it here. Same type of problem here.
B. So
All right, sorry, I was just looking at this. You say it's B. Does this graph open up or down?
down.
Down. Okay, so its vertex though, its vertex is at -4, 5. Does that change your answer at all?
Yes. I did the thing again where I mixed up the numbers in the
Yeah,
order.
easy to do.
Yeah, but it's D instead.
So D opens up, C opens down. And it's all based on that negative out in front.
Oh, that thing. I thought it was just there to trip me up. It was.
It's reflection over the x-axis.
Uh,
All right. So we're gonna switch to kind of a related topic here. I'm gonna graph some things for us, and grab a snip here, put it into the workspace here that we're doing. All right, here we go. Okay, so this is a graph of a quadratic. It's got that U shape to it. We're going to now focus on what are called inequalities. So let's just consider this y. This graph is y. Where is y less than or equal to 0? And to help here, I'm asking where it's below the x-axis. So when you look at this graph here, where do you see it below the x-axis?
On the the bottom half
Okay.
of the.
Is it 1 point or is it more than 1 point that it's below the x-axis?
It's several points.
Yes, it's everything. I think I'm gonna what I'm shading is what you're referring to earlier. Did you mean this
Yeah.
kind of, yeah, okay. What is the X value that uh, bounds it on the left?
Negative 2, 0.
It's just the X value.
Oh, okay, negative 2.
Okay. And how about on the right? What is it bound by?
3.
3. So would you agree that Y is less than 0 when X is between -2 and 3?
Yeah.
So we say that using this type of note. Sorry, I got that backwards. We say that using this type of notation. This is called a compound inequality. Have you seen that before? Something
Not
like
yet.
this? Not yet. Okay. Well, you will be seeing it soon. That's for sure. Okay. Do you see how I got those two numbers though?
Yeah.
All right. Now let's do kind of a related one here. Let me change the color on this. All right, new question here. All right, so this quadratic is opening down. And I want to know this time, we're going to call this y. I want to know where y is greater than or equal to 0, meaning above the x-axis.
Between negative 4 and negative 1. Or not, between negative 4 and 1.
Yes, very good. Very good. Okay. So it sounds like this is the typical path in this course. It sounds like you're actually going to start with what are called linear inequalities. So that would look something like this, like 2x minus 5 greater than 13. Okay, have you seen something like this before?
I have.
You have. Okay, so you might get a brief review on this. Do you remember how to solve something like this?
Um, I do. It's kind of similar to I can never remember all the math vocabulary, but it's that one equation.
Okay, yeah. So you're gonna add 5 to both sides. Okay, and the reason you add 5 to both sides is you look at the side of the equation with x, and you say, okay, I've got 2 times x minus 5. You're gonna undo subtraction by 5 by adding 5. So this becomes 2x greater than 18. Now what do you see as far as how to solve for x? How do you undo this multiplication by 2?
Divided by 2.
Divide by 2. So this is x greater than 9. Now on a number line, here's what that means. Imagine 9 is right there. It means all the numbers bigger than 9. So everything to the right of 9. You say you've seen this before?
Yeah, I've seen this before.
Okay, so here's a question for you. Is 8 greater than 9? Is this true or false?
It's false.
It is false. Okay, I'll have you try one real quick in the time we have left here. 2x minus 3 less than minus 7. Do you want to try solving this one on your own?
Sure. x is less than -2.
Okay, I agree. So here's a question for you. Is -3 less than -2? Is this true or
This is
false?
true.
This is true. Yes, very good. That's a good sign. A lot of students really struggle with like knowing where these numbers are on the number line. And that is going to be really helpful when you go to graphing inequalities.
All right.
All right. So that'll probably do it for us for today. Kind of hit on a variety of topics there. We did some quadratic stuff. We did